Welcome to Unit 6.2. Today we're going to be talking about approximating areas with Riemann sums. Like I said in the other video, if you want to find the area of your function, but you didn't have clean geometric shapes to divide your function into, what you would have to do is use Riemann sums. Riemann sums just means that you use mini triangles and using these mini rectangles, you would find the approximate area of the function. Now let's look at different methods. The first method we're going to start with is the right rectangular method. This means that the right part of your subintervals, which is basically your rectangles, will touch the curve, meaning that it will touch the line in your function. So, solving using the right rectangular method, the first thing we have to know is that our formula is your width times your f of width, and then you add that to how many subintervals you have. Now, to find the width of your function, you would do b minus a over n. Now, when finding the area, they're always going to give you an interval. So your intervals will be a and b, hence where you get your b and your a variable from. And then your n just means how many subintervals you're going to use. That will also be given to you in the question. So once you find your width, you plug it into the formula, and then you add it with how many subintervals you have to get your approximation. Now let's do the left rectangular approximation method. Now, with this method, the left part of your subinterval, I'm going to abbreviate it real quick, will touch the curve. Very important that it will touch the curve. And to find this, you would do the same thing that you did with the right method, and you would find your width. Remember that width equals b minus a divided by n. And then you would do the same, where you do the width times your f of width. And you would continue that with how many subintervals you have. One key thing to note is that the more rectangles equals a better estimate. Now let's look at the midpoint. Riemann sum. Now this just means that you're going to use the middle of the subinterval. So this formula would look like your width times your f of the midpoint and you would do that depending on how many subintervals that is required. Lastly, let's look at the trapezoidal random sum. This method is when you connect the left and right side together. Note that this is the most accurate approximation you could get. And to find this, you would say that your area equals 1/2 B1 plus B2 times your H. Your B1 is your left point, and your B2 is your right point. And then H will equal your height, which also equals your width. Let me show you a picture. This is what your mini rectangles on the interval, let's say your interval, would look like. So your B1 would be on this side, your B2 would be on the other side, and your H would be your base, which also, like I said, equals the width. And to solve using trapezial, at the end, you always want to simplify by factoring. Easiest way to find your area. So your trapezial, I feel like I'm saying it wrong, your trapezoidal sum equals 1/2 times your right sum plus your left sum. And that's how you would find your trapezial. And that is all the methods that we're going to talk about. That is all for 6.2. Thank you for watching.